Okay, so we will be solving problems under this chapter, the Quantitative Chemistry chapter, or the first chapter of IB Chemistry. So basically, problems in this chapter focuses mostly on calculation, and it involves stoichiometric problem. Okay, the first step in answering a stoichiometric problem is to write, or for you to understand first, what takes place in the reaction. Okay, the best way to understand what takes place in the reaction is for you to write the chemical equation. Let's say, for example, in this problem, calcium carbonate is reacted with excess hydrochloric acid, and then the remaining hydrochloric acid is then titrated with sodium hydroxide. Okay, so this is an example of a back titration. The first step, as I've mentioned earlier, is to write the balance equation. So calcium carbonate reacted with excess HCl, producing calcium chloride and water and carbon dioxide. Okay, so you have to present a balance equation. Okay, the remaining HCl is then titrated with sodium hydroxide, producing salt and water. Okay, so it will be easier for you to solve this type of problem if you've understood the reaction take place. Okay, so basically this type of question will have, you will earn 7 marks, okay, by solving values or step-by-step values. Let's say, for example, for letter A, you were asked to calculate the amount of moles of HCl. Okay, so first we solve this first question. Okay, first we solve this question. Okay, so what are the given values for this problem? So you have the volume of HCl, and then you have the concentration of HCl, and you also have the mass of calcium carbonate. So those are the given values. Given values, volume of HCl, concentration of HCl, and then you have the mass of calcium carbonate, which is 188 grams. And then you were asked to find the You were asked to find the amount of HCl in moles. So we were asked to find the amount of moles of HCl. Now, what formula are you going to use to solve for the amount of HCl? So basically, you have the concentration and you have the volume. You can actually use the molar concentration formula, wherein concentration is equal to moles over volume. Take note, you were asked to find moles. By multiplying the concentration and the volume, you will be able to find the amount of HCl, or moles of HCl. But take note, the unit of volume here is in dm cube. Okay, it's in dm cube. So the unit, or rather the unit of the volume given is cubic centimeter. So you need to convert this to dm cube first before multiplying it with the concentration. Or you can divide it by 1000, or moles is equal to concentration times the volume. Okay, so you have here the concentration, which is 0.200 mole dm cube times the concentration, So it's in cubic centimeters, so you need to divide it by 1000 to have a EMQ. Moles is 0.00544 or times 10 to the negative 3 moles. Okay, so this is your answer, and then you will get 1 mark for correct significant figure of the values. Okay, so we will move on to the next problem, rather the next question for the same equation. Okay, so we're going to solve the second question. Second question for this problem. So for 1 mark, you were asked to calculate the amount of acid that is in excess. Okay, you were asked to find the. So remember the second equation wherein the remaining acid, or rather the remaining acid is titrated with sodium hydroxide. So we're going to calculate the number of moles of this acid. Okay? Okay, so based on the given values, we have the volume of sodium hydroxide, which is 23.80 cubic centimeter, and we also have the concentration of sodium hydroxide, which is 0.10 mole EM cube. Okay, and then you were asked to find or to calculate the moles of HCl. Okay, so based on the chemical equation, we know that 1 mole of sodium hydroxide is needed to neutralize 1 mole of HCl. So if we calculate the moles of sodium hydroxide, we were able to find the moles of HCl. Okay, so we can say that moles of NaOH is equal to moles of HCl. Okay, so using the formula that we've used in letter A, wherein concentration is equal to moles over the volume. Take note that the unit should be in EM cube. So we can actually calculate the moles of sodium hydroxide by multiplying the concentration and the volume of sodium hydroxide in EM cube. Say for example, moles of NaOH is equal to 0.1 mole per dm cube times the volume, which is 23.80 divided by 1000. Okay, and moles of sodium hydroxide is equal to 0.00238 or 2.3 times 10 to the negative 3 moles. Okay, so since we stated that moles of NaOH equal to the moles of HCl, we can say that moles of HCl is 2.38 times 10 to the negative 3 moles. Okay. Let's solve the third question, wherein you were asked to calculate the amount of HCl that is reacted with calcium carbonate. So previously, we were able to calculate the amount of HCl that is present in excess, okay, and then also the amount of HCl that is titrated with sodium hydroxide. Now, to find the amount of HCl reacted with calcium carbonate, all we need to do is to subtract the amount of HCl. So from our previous, okay, we were able to solve actually that this is 5.44 times 10 to the negative 3, which not all of them is reacted with calcium carbonate. And we also found out that the amount of HCl that is left or remained from the reaction, which is 2.38 times 10 to the negative 3 moles. Actually, by subtracting this moles to this moles, we were able to find the amount of HCl reacted with calcium carbonate. Okay. So, moles of HCl reacted is equal to moles of HCl, which is present in excess, minus the moles of HCl that is left from this reaction. Okay, so initially we were able to calculate this value. So we have 5.44 times 10 to the negative 3 moles minus 2.38 times 10 to the negative 3 moles. So giving you the moles of HCl reacted to calcium carbonate, which is 3.06 times 10 to the negative 3. So you will have 1 mark for the correct significant figure and correct values. Okay, for letter D, you have to state the equation for the reaction of HCl with calcium carbonate in the eggshell. Now this is for 2 marks. So earlier we were able to write the equation, but for you to be able to get 2 marks, you need to balance the equation. You need to write the correct chemical symbol, and then you have to give the state symbol of each substance. Okay, reaction with calcium carbonate. So in this case, in this problem, this is solid plus HCl aqueous. We will produce calcium chloride aqueous, water, and carbon dioxide gas. Okay? So, 1 mark for balance equation and for the correct chemical symbol, and 1 mark for the state symbol. Okay, for letter E, you were asked to calculate the amount of moles of calcium carbonate in the sample of the eggshell. And we know, based on the equation, that 2 moles of HCl will react with calcium carbonate. And from earlier, we gathered that 3.06 times 10 to the negative 3 moles of HCl is actually reacted with calcium carbonate. Based on these 2 information, we will be able to solve or calculate the amount of calcium carbonate reacted with HCl. So we know, based on the equation, that for every 1 mole of calcium carbonate, 2 moles of HCl is needed. Okay? So hence, to calculate moles of calcium carbonate, we just need to divide 3.06 times 10, the moles of HCl, by 2 to find the moles of calcium carbonate. Okay, or you can multiply it by 1/2. Either way. So 1 1.53 times 10 to the negative 3 moles. Okay, so this question is for 2 marks. 2 marks will be awarded for correct final answer. Okay, for letter F, you were asked to calculate the mass. You were asked to calculate the mass and percentage by mass of calcium carbonate. Okay, from previous question, we were able to gather the moles of calcium carbonate, which is 1.53 times 10 to the negative 3 moles. So we can use that by multiplying it. Okay, to calculate the mass, we need to multiply MR by the number of moles. So we have the MR of calcium carbonate and we have the moles of calcium carbonate from our previous calculation. By the way, this question is for 3 marks. For you to have 3 marks, you need to calculate the MR, you need to calculate the mass, and you need to find the percentage by mass of calcium carbonate to have 3 full marks. Okay, so you need to, I'm pretty sure you know how to calculate the MR. Okay, the MR of calcium carbonate is 100.09 times the moles of calcium carbonate, which is 1.53 times 10 to the negative 3. The mass is equal to 0.153 grams. So 1 mark for calculating mass and 1 mark for finding the MR of calcium carbonate. Okay, next we need to calculate the percentage by mass of calcium carbonate. So we have the mass of calcium carbonate, which is 0.153 grams. Okay, percentage by mass is equal to the mass of calcium carbonate and the mass of our eggshell. So from our first question, we found out that the mass of the eggshell is 0.188 grams. Okay, so we just need to divide the mass that we get from multiplying MR by the moles divided by 0.188 grams times 100. Okay, percent by mass of calcium carbonate is equal to 81.5%. Okay, for letter G, deduce one assumption made in arriving at the percentage of calcium carbonate in the eggshell sample. From our previous workings, we calculated the moles of calcium carbonate using the moles of HCl. To accept our data, we need to assume that only calcium carbonates react with HCl, and if there are any impurities, they are inert or they will not react with HCl, because our basis in calculating the moles of calcium carbonate is based on the moles of HCl reacted on the eggshell. Okay, so we're going to solve the second problem for the same chapter, quantitative chemistry. Okay, like what we did earlier, the first step in solving this type of problem is to write the chemical equation. Okay, so for this specific problem, you will be gaining 9 marks. Okay, in solving each question. So we need to identify first what are the reactants involved in the reaction. First, we have the alkaline metal sulfate, and then we have the barium chloride. Okay? We don't know the identity of the alkali metal, but since we know that it's in group 1, we can actually write the chemical formula, which is X2SO4. So since it's unknown, we can represent X as the unknown alkali metal reacted with barium chloride. So in this reaction, you will form a precipitate, which is barium sulfate. Now for the first question, for 2 marks, okay, this is for 2 marks, you were asked to calculate for the moles or amount of barium sulfate formed in the reaction. So on the problem, what are the given data that can be used to calculate for the moles of barium sulfate? So basically, we can use the mass of barium sulfate formed in the reaction. Now, 2 marks, 1 mark for solving or for calculating the MR, and 1 mark for solving the moles of barium sulfate. Now, how are we going to calculate for the barium sulfate? What formula are we going to use? So, to find the moles of barium sulfate, we need to divide the mass by the MR. Okay? The MR of barium sulfate is 233.4. Okay? MR of barium sulfate is 233.4. I assume that you know how to calculate the MR. Okay, so mass is 0.672 divided by the MR, which is 233.4. Moles of barium sulfate is 2.88 times 10 to the negative 3. Your answer can be in the standard form or in scientific notation, as long as you have the correct number of significant figure, which is 3. Okay? Now, for the second question, for letter B, so this is the moles of barium sulfate. Now, for letter B, for 1 mark, you were asked to determine the amount of moles of alkali metal. Okay? Alkali metal sulfate. Okay. So you were asked to find the moles of alkali metal sulfate. So we can use the balance equation in finding the moles of alkali metal sulfate. So we know that the moles of barium sulfate is 2.88 times 10 to the negative 3. And based on the balance equation, 1 mole of barium sulfate produced from 1 mole of alkali metal sulfate. So hence, we can say that moles of barium sulfate and moles of X2SO4 or alkali metal sulfate is the same. So for the answer for letter B is 2.88 times 10 to the negative 3 moles. Okay? Okay, let's continue to letter C. Okay, letter C, you have to determine the molar mass of alkali metal sulfate and state its unit. So this is for 2 marks. Okay, 1 mark for stating the unit and 1 mark for finding the value of MR. Okay, now to calculate the MR of alkali metal sulfate, okay, we can use the formula MR mass divided by moles. Now, from the previous question, we were able to find the moles of alkali metal sulfate, wherein the moles of alkali metal sulfate is 2.88 times 10 to the negative 3 moles. And the mass of our alkali metal sulfate is stated in the problem, which is 0.502 grams. Okay, so by dividing 0.502 grams by the moles, the MR is 174. And you need to state the unit to get the full marks. Okay, now let's proceed to letter D. Deduce the identity of the alkali metal showing your workings. Now, based on the calculated MR, we can actually find the AR of our alkali metal. How? Okay, we all know that MR is the sum of the AR of all atoms present in the compound. So hence, to calculate the AR of your alkali metal, so based on here, we have 2 times X, since we don't know the AR, plus the AR of sulfate, which is 32, plus 4 times 16 for the oxygen. Total is 174. Hence, X is equal to 39. Okay? Now, using the periodic table, we will be able to identify that the element that has molar mass or AR of 39 is actually potassium. So, for this question, for letter B, you will have 2 marks. 1 mark for solving the AR of potassium. 1 mark for solving the AR of your alkali metal, and 1 mark for identifying your alkali metal, which is rather potassium. Okay? Now for letter E, write an equation for the precipitation reaction including state symbols. So now we write the chemical equation using the identity of our alkali metal. So instead of X, we're going to write potassium sulfate produce potassium chloride. And take note, this is for 2 marks, so it should be balanced, and the chemical formula for each compound should be correct, and you have to include the state symbol. So we know that potassium sulfate is dissolved in water, hence this is an aqueous solution, and our barium chloride is also an aqueous solution. And of course, barium sulfate is a precipitate, hence the identity is solid, and KCl is an aqueous solution. So for writing the correct chemical equation, or rather for writing the balanced chemical equation and the state symbol, you will gain 2 full marks. Okay, so we're going to answer the third question under the same chapter, Quantitative Chemistry. So for letter A, the first question is, or rather, the first problem is, for letter A, you need to write the balance equation for this reaction. Reaction between silver ions and your aqueous ions. So, obviously, you don't know the identity of your element, hence it's X. So, you have here XO4 3 minus. So, since an ion is an aqueous, okay, react with silver ions, positive, so it's aqueous as well, forming a precipitate, Ag3XO4, so it's solid, okay? So for answering this question, you will earn 2 marks. 1 mark for balancing the equation, and 1 mark for stating the, or rather including the state symbols. Okay, for letter B, you were asked to calculate for letter B first question, you were asked to calculate the moles of silver ions. Okay? Moles of silver ions. So based on the given values, we can calculate the moles of silver ions. So we have here the volume, which is 41.18 cubic centimeter, and then also the concentration of silver ion is given as well. So from the previous problem that we solved, to calculate the moles, all we need to do is to multiply the concentration of silver ions by the volume. And take note, the volume should be in dm cube. Hence, we multiply it by 0 mole dm cube per dm cube times the volume, 41.18 cubic centimeter. You need to divide it by 8,000. Okay, hence, moles of silver ion is 8.401 times 10 to the negative 3 moles. So this is the answer, okay, for this question. Take note that you need to give your final answer with the correct significant figure, which is 4 significant figure. You can either write it as scientific notation or the standard notation. Okay, now for the second question, you were asked to calculate the amount of moles, or rather amount in moles of the precipitate form. Okay, you were asked to calculate. So we can use, since we know the moles of silver ions, we can use the balance equation to calculate the moles of our precipitate. The relationship between silver ions and your precipitate is 3:1, or the ratio is 3:1. For every 3 moles of silver ions, you will form 1 moles of your precipitate. So since we have the moles of our silver, or rather, since we have the moles of silver ions, we can divide this by 3 to find the moles of the precipitate. Okay? So we just need to divide this by 3. Okay? Because the relationship between silver and your precipitate is, or the ratio is T:1. So, okay, now to find the moles of your precipitate, we divide this by the value by divided by 3. Okay, so hence the moles of the precipitate is 2.800 times 10 to the negative 3 moles. Again, you need to express your final answer with 4 significant figures, either using scientific notation or your standard notation. Okay, now for the third question, you were asked to find the molar mass of the precipitate. Now, to find the molar mass, to find the MR, we need to divide the mass by the number of moles. Okay, so in this case, we already have the moles, and the mass of the precipitate is given in the problem. So we just need to divide this by the moles that we've calculated earlier. Okay? So hence the MR is the MR is 418.6 gram per mole. Okay? Now for the last question, okay, by the way, that is for 2 marks. Okay, so correct sig fig and then the unit. You have to state the unit. Okay? Okay, for the last question, you were asked to determine the relative atomic mass of X. You need to find the AR of X. Okay, like what we did earlier. Okay, since we have the MR of your precipitate, we can actually calculate the AR of X. Okay. So let's see, for example, Ag3XO4. Okay. So the AR of silver is 3, or rather 107.87 plus X plus 4 times 16 is equal to the MR, 418.6 gram. Negative. So the AR of X is equal to 30.99. So you will have 2 marks for calculating the AR of X and for identifying what is X. X is phosphorus. Okay, so you can use the periodic table to find the identity of your X. Okay, so that's it for the first chapter.